Alright, welcome back, and this is Chipmaster again, and I was on a break for the past couple of months. I think it was about 3 months, yeah, and I started my live stream on Saturday. So as you can see, it's a not so bright early Monday morning, and I'm going to do a video as usual, another repair video on a HP, and they said that it's written on it a dead board. Right, it says dead board. Alright, so let me see what can be done. So I'm going to plug in the power. I shift that. Turn off some lights. All right, so power supply here. It's an alley. All right, so I'm gonna plug in the power. No, this port doesn't feel right. Oh, so it's not snapped in. All right, so I plug in the power, and there's no lights. All right, I should get an orange light here. Oh, as you can see, the current is jumping. Look at the DC power supply. Take a look. All right, so it's the voltage is dropping to 19 volts, 0.9, and I'm getting 40 milliamps to 0, and it's doing that over and over repeatedly. So that indicates I have a short. Right, so I have a short on this motherboard. On this laptop as a short. Seems it's on the 19 volt rail. So I'm going to have to take it apart to see what's happening. Alright, so let's start. .9% of the time the CPUs are always broken on these units, right? Because they uses the Intel Atom series, the system on a chip SoC, and it's the Gemini Lake SoC, and they're easy to break because they are low powered, only consume 4.5 watts of power. So they don't carry a fan. Oh, there's another screw under here, I forgot. Oh, I did remove this one. Alright, so any fault with this laptop, I should be able to fix it because I have parts. Alright, so before I go any further, let me just do a visual inspection. Alright, so this is standby area here. Alright, so this is the RAM supply. Am I correct? No. This is the RAM supply area here. Right, this is the RAM PWM chip, and this is the RAM coil. Right, and this is 5 volt standby, and we have 3.3 volts here, and I don't see any form of burn or explosion rather. I'm not seeing any explosion along this side. Let's take a look at this side onto the embedded controller section. This is the embedded controller. I'm not seeing any obvious any burn or any liquid spill or any explosion on this side as well. Alright, so I can now continue the disassembly. Oh, this is a Core Series CPU. It's a AMD. Yes, it's a Ryzen 3, as you can see. These Ryzen CPU always break. This is a Ryzen 3 CPU. Ryzen 3. I wasn't looking at the sticker because 99.9% of the time these are all Intel Gemini Lake. I think this is the Bristol Ridge, I believe. The code name that AMD gives it. We have Stony Ridge and you have Bristol Ridge for the Ryzen series, Ryzen 5, Ryzen 7, and so forth. Alright, so I don't have a Ryzen CPU, so if the CPU is dead, then that is game over for me there, because the Ryzen CPU is a bit expensive. Okay. Okay, so just checking the back side of the board here. Alright, so all is well on this side as well. No burn, no explosion, no liquid intake whatsoever on this side of the board. Alright, so all good. Okay, so let me check all coils. I know there's a short on the 19-volt rail, and if an upper MOSFET is broken, then that means the CPU will also be broken as well with that 19 volt. Alright, so I'm checking bias pin number 8 and I get 197. Let me turn off additional lights. Alright, bias pin number 8, I get 197. Alright, 3.3 volts is here. I get 356, 5 volts. I get 380 RAM supply. I get 37. That's also good. Battery charging, I get 515. Alright, so I'm gonna check on the adapter input current sensing resistor. Right, and that will be, let me see, I'm searching for it because there's no schematic for this board. Alright, I think this is the adapter current sensing resistor. Yes, and I have a short here, 000 to ground, right? 000. As you can see, I'm having a short there. Alright, so I'm going to do the regular injection method. Right, 1.8. This is VDD, VDDP, VDD, CR1, VDD 1.8 always. VDD 1.8 always is okay. So 3.3 volts is VDD 3.3 volt always. Right. Then you have VDD, VDDP, and VDD CRSOC. And VDD CPU core, which is the VDD underscore SOC underscore CPU. That's 2. And VDD underscore North NB, North Bridge power supply here, which is 4. Right, so there's no short there as well. Right, because if one of these dual MOSFETs are broken, then the CPU VDD VCC VDD underscore CPU underscore SOC is shorted. That's its core supply for the Ryzen, for the AMD. I'm giving you the standard naming conventions for the AMD APU, which is the Ryzen standard name. Right, and this is the VDD CRNB North Bridge power supply, and that's 4. So there's no short there. So I will now inject. All right, VPP 2.5 volts. All right, 343 VPP. This is 2.5 volts for the RAM. Oh, so this is VDDCR underscore VDDP. VDDP. I have 21. Right, VDDCR underscore S5 197. So that's good. So all the power rails are okay for the standby and the CPU power supply and the North Bridge power supply. So I will inject. And then I'll put this under the camera, thermal camera. Alright, so I'll now solder on the adapter current sensing resistor here. And I'll go under the camera in a few. Okay, so I'm now on the camera, and I will now seek, and I will adjust my temperature range here so I can see a better perspective of the image under the camera. So I will give power. As you can see, I'm now getting 4 ampere. So this side is clear. There's no short on this side. So let me go over to the CPU section. I'm injecting approximately 2.6 volts at the moment. All right, so I'm going to give power again. I'm seeing some burn. I'm seeing something hot on this side. Let me flip the board. Let me switch the board around to the camera section so I can see. So as you can see, let me reseek. Up this section here was getting hot. Right here. Right in this section here. Right in this section here was hot, so let me give power again. Let me seek. Alright, we seek. Alright, I give power. There we go. So I'm getting 34 degrees right there. 35 degrees. Let me take a, so that's right there at the cursor. The cursor is right here, so it's telling me that there's a hot spot there. Let me just flip the board over. As you can see, there's no component here, so it's definitely on this side of the board. So it's somewhere right here. Could it be that this cap is broken? Let me give power again. So it's right here, hot spot. So it's that capacitor then. Okay, so I'll stop the power and head back to the microscope. Alright, so let me go under the microscope. Alright, so ready? Alright, so I was getting a hot spot right here, somewhere right here, right in this section here. So I'll use the 99.9 and give power again and see. Alright, so I'm gonna put some alcohol right here. I give power. I give power. Alright, so I'm not seeing anything evaporating quickly. I'm not seeing it. And there's no components on this side. So it's definitely on this side. I'm going to remove this cap. I'm going to remove this one. Let me see this one. This one looks... Alright, so I'm going to remove this capacitor here. This one, and then see if the short is cleared. Let's move this out the way. Waiting for the iron to get hot. Alright, so I move that one first. Alright, let me check on the current sensing resistor. Right, the short is cleared. I get 450 now. So it was definitely that capacitor there. Right? Oh, I know why. Why it's not getting hot. Because I was injecting only 2.4 volts. I should have injected at least 10 volts. Oh, sorry. Yeah. So that was the problem. I should have injected roughly 5 volts so it would get hotter. And I wasn't realizing that I was only injecting 2.6 volts. But I had to do that because I don't know if the upper MOSFET was broken. So I didn't want to send too much voltage to that section to send too much voltage to the CPU to even burn the CPU more. But most times if the upper MOSFET is broken, then the CPU is also dead, so it doesn't really matter. Alright, so I will now completely remove this capacitor here. As Sorin would normally say, this is an easy pizza, innit? Alright, so I'm just clearing this pad now. This is a 0603 capacitor, maximum 25 volts, with a microfarad of roughly 330 microfarad, yeah? Alright, so alright, so clean. Alright, I'll just put a new one there. Alright, there's a new one. Alright, so let me check on that section again. Alright, current sensing resistor, I get 429. Excellent. So it wasn't the upper MOSFET. Alright, and which is good. So the CPU is saved by the cap. Alright, so I'm going to give power now, and I'm going to check all supplies in an on condition. Okay, so I have now connected the basics. Alright, so should get a white light now. Yes, there is the white light. Right, so I have the white light. I don't think I will get standby voltage at this moment, because it normally, on these boards, it's normally generated after the switch. Right, after the EC reads the program, then it will shut down 3 volts and 5 volts and wait for the switch. Right, so this is the new standby process for most motherboards. which was implemented back in the 6th generation CPU, the ACPI consumption, where 3V and 5V is, but some boards have the 3V and 5V before, some boards have it after the switch, right? And this is a specification which is used to save power. So as you can see, I might not get 3.3 volts here. I have to wait until after the switch is pressed. Alright, so here we go. See, no 3.3 volts, no 5 volts. So I have to press the switch. Alright, so I'm going to press the switch now. Right, the fan spins and the current consumption is now 300, 400. Alright, so 3.3 volts now. Hold on, let me stop the power. Alright, so I'm just waiting. Wasn't getting any. See, no 3.3, no 5 volts. Alright, so I'll now press the switch. Alright, so 3.3 is there. 5 volts, 1.2 volts, 2.5 volts, 2.5 volts is there. Alright, CPU core, VDC CPU. So this is VDD SoC underscore CPU, and this is VDD CR underscore NB, which is the North Bridge power supply. Alright, 0.7. As you can notice the difference between the two power supply, one is 1.1 volts and one is 0.7 volts. So this is the North Bridge power supply. So there's a integrated North Bridge inside of the Ryzen APUs. Right, so that's a North Bridge power supply. Right, and I'm gonna check for VDDP and VPP power supply. I see 2 coils here. Alright, so one should be roughly 0.9, one should be 1.0 volts. Let's see if I'm correct. And this is the other standby voltages for the Ryzen's. Right, so it's VDD-CR, VDDP, so it's VDD 3.3 volts, VDD 1.8, VDD-CR SoC, and VDDP. Right, so 3.3, 8 volts, right, sorry, 3.3, 1.8 volts, 1.0 volts, 0.95 volts. Right, so I give power and press the switch. Alright, I'm just waiting this thing as I play. Let me go for the other DC, the other plug. Tight. Yeah. Alright, so I'm gonna check these 2 small coils. See, this is 0.75 and this one is 1.8. So this is 1.8. So this is VDD-CR. This is VDD-CR, right? SoC, and this is 1.8 volts. Let me see under the heatsink. We have another coil here. So let's see if this is VDDP. VDD-CR is normally 0.7 volts, between 0.907 to 0.8 volts. 0.9 VDD-CR SoC is normally 1.0 volts. I'll just call it a volt then in most cases. Alright, so I'm pressing the switch now. Excellent. So this is, so I thought this was the 1.8 volts, but this is VDD-CR SoC. Alright, and the other one that I checked is VDDP. Alright, so they're all good. So those are the main standby voltages for the AMD APUs, right? So I'm going to plug in I'm going to connect the laptop. I'm going to assemble the laptop, sorry. I'm going to assemble the board and get back to you in a few. Alright, so I will just the last step of the assembly. Alright. I hope the battery has power. No, it doesn't. Alright, so time for the main test. Just light the light here. Okay. Right, so I got an orange light. Alright, so as you can see, the orange light is there, and I'm taking 160 milliamp, as you can see, and it's now trickle charging. Right, in a few it will go into the fast charge mode. Right, so this is doing a pre-charge, which is called the trickle charge, because the battery threshold voltage is below the standard threshold. So once the battery reaches the threshold for charging current and charge voltage, then it will bump up the current to a roughly 1.3 ampere to 1.6 ampere, and that's fast charging. Right, so this is a safety precaution, right, which is implemented inside of the I2C line. Right, and it is used to protect the battery so that you don't burn the battery and your battery don't explode while using it. Anyway, so I'm going to give power. Alright, so it's doing its starting up sequence. There we go. As you can see, the current is now going up to, it's jumping, so it doesn't reach its full charge threshold as yet. And there we go. Repaired. Alright, so I hope you enjoyed the video there. Right, and I hope you learned something. So in the next video, I will fix something for you in another video. Bye.